Now here we look at the Williamson ether synthesis. The Williamson ether synthesis, based on its name, it's a way to make ethers. Originally discovered or credited to Alexander Williamson all the way back in 1850. And so this is a reaction that takes an alcohol and an alkyl halide, and then under strongly basic conditions allows us to form an ether. Mechanistically, this reaction is pretty simple. It's one of those cases that we give a separate name to a reaction, even though it's really not that different at all from other reactions that we're familiar with. There's two basic steps in the Williamson ether synthesis. The first step is just a deprotonation using the strong base. And the second step is an SN2 reaction. And that's all there is to this mechanism. So again, we can start with an alcohol like this. We add our strong base, commonly sodium hydride for this reaction, and that's just going to deprotonate our alcohol. We form an alkoxide anion, and then we add an alkyl halide to this. Now we do have to be very, very careful in this reaction as to what alkyl halides we use. Because as with any substitution process, elimination does compete here. And in fact, if your alkyl halide has protons available for elimination, elimination will almost always win because these alkoxide anions are generally very strong bases. So the alkoxide, once you've formed it, if it can't eliminate, it'll just do an SN2 reaction, kicking out the leaving group, and we make an ether. Where might we run into a reaction like this? Well, one application of this reaction is if you start with T-butyl alcohol and add methyl iodide to it, again under strongly basic conditions, you can form MTBE, which is used as an additive for gas to help reduce carbon monoxide emissions.